Alright, in this video we're going to talk about Unit 11, Objective 2, Alternating Series Test. So the alternating series test is going to be used for a very specific type of series. Spoiler alert, it's going to be an alternating series. An alternating series is a series whose terms alternate between positive and negative. So here's our alternating series test. It says, suppose you have a sum, or we'll call it a series. You have a series, and we'll call it A of n. And then we're going to be very specific. When A of n equals either negative 1 to the n power times some other series B of n, or A of n equals negative 1 to the n plus 1 power times some series B to the n. Then your original series will converge if the following two things happen. 1, B of n is decreasing. And 2, the limit as n goes to infinity of B of n equals 0. If those two conditions are met, then your alternating series is going to converge. So let's look at an example, and then we'll be finished with the video. So we'll say, does the following series converge? So the series from n equals 1 to infinity of negative 1 to the n plus 1 power times the square root of n plus 1 over n plus 1. So we have our alternating series. We can see that because we have the negative 1 to the n plus 1 power. How we're going to know this alternates is we have that negative 1. So negative 1 to an even power is going to be 1, and negative 1 to an odd power is going to be negative 1. So it's going to make our terms bounce back and forth between positive and negative. So if we're looking at this, our A of n is all of that stuff that you see. So our B of n is everything without the negative 1 to the power. So B of n is just going to be the square root of n plus 1 over n plus 1. So there's two conditions that need to be met if we're going to have a convergent alternating series. So the first one is, does this thing decrease? So are we decreasing? So we need to check. So we plug 1 in. So we're going to get square root of 1. So we'll say if n equals 1. We're going to get square root of 1 is 1, plus 1 is 2, over 1 plus 1 is 2. So when n equals 1, our series, our term is 1. If we go to the next term, so if n equals 2, we're going to get the square root of 2 plus 1 over 3. Now, we have to decide, is that less than 1? Well, the square root of 2 is less than 2. So something less than 2 plus 1 divided by 3 is going to be less than 1. So yes, we are decreasing. So we need to look at our second condition. Now, once you get to this spot, if your function or your series is not decreasing, then you can stop here. You can immediately say that your series diverges because we need to meet both conditions. But we met our first condition, so let's look at the second condition. And the second condition is, does the limit as n approaches infinity of B of n equal 0? So we're going to look at this and we're going to say the limit as n approaches infinity of the square root of n plus 1 over n plus 1. Using our rules for horizontal asymptotes, we're going to compare the degree in the numerator and the degree in the denominator. Degree in the numerator is 1/2, denominator is 1, so our denominator has a larger degree, which means our limit does equal 0, so we have a convergent alternating series. So that'll do it for this video. We will see you in the next one.